And Gary, if you don't mind, I'll kind of run things today because I want to talk about the proposal.
Yep, go for it.
All righty. Well, good afternoon, everybody. Thank you for coming to the SEQP Planning Telecon today. So as I mentioned, we have a grant proposal to support the effort, and that's as I was explaining to Gary, the proposal is technically due November 8th to NASA, but we have to have a really good solid draft of it into my university's administration by next Tuesday, because then they need to review it before they will actually submit it. So I've got quite a bit of work to do on this. The proposal's going to fund things. Some of the most important things it funds are efforts like a postdoctoral scholar to do scientific analysis on it. There's also going to be some support for some undergraduate students and a research engineer, and some travel to go to meetings and to publish the papers and things like that. And in addition to just the money, having these grants really helps these it provides a lot of motivation for us to be able to do these things. The universities are much more willing to give us time to work on this stuff if we actually have grants associated with them. So that's what we're doing. And the other thing that's really nice about the process is in the grant planning process, we're really forced to identify what science questions we're going to go after, how we're going to do it, and what the the methodology for it. So we really get to kind of clarify a lot of these thoughts right at the beginning. So you can see in the link in the chat, that's the proposal call that we're submitting to. Also, in that link, you can see that there's a proposal checklist, which I can put directly in. Let's see. There's I'd say like three important links here. The link I just put in is the actual text for this particular call about the Eclipse. And then there's a checklist here. The last one is a checklist. That's everything that has to go into the proposal. So I have the proposal set up in Overleaf so far, and here's a table of contents. So we can see that the main document that we really need to worry about here is this scientific, technical, and management section. And so we have research objectives and significance, the perceived impact of our work, the relevance to the program element, the technical approach and methodology. I then divided that into observations and modeling, potential sources of uncertainty, mitigation strategy given obstacles, team member roles, and data sharing and archiving. And all of these top-level headers are coming right out of the checklist. We've already written a project summary, which I've now incorporated as the research objectives and significance. So what I'll do is I'll go through and I'll read that right now. So it says, on April 8th, 2024, a total solar eclipse will traverse North America in a southwest to northeast path, starting in Mexico and ending in Canada. During a solar eclipse, light from the sun is temporarily blocked by the passage of the moon. In addition to a tremendous visual display, this temporary cessation of insolation causes both a reduction in photoionization and a cooling of the atmosphere, leading to dramatic changes in ionospheric electron densities and dynamics. Eclipses are distinct from day to night or vice versa transitions because of the shorter impulse-like duration and the supersonic motion of lunar shadow. As such, solar eclipses serve as constrained ionospheric experiments, one in which major inputs to the ionosphere are known a priori, a rare occurrence in the field of ionospheric physics. Thus, studying the ionospheric response to this solar eclipse is of critical importance to understanding the ionosphere, thermosphere, mesosphere, ITM system. This project will study the ionospheric response of the 2024 total solar eclipse through a series of large-scale citizen science experiments known as the Solar Eclipse QSO parties, or SEQPs. The data for these experiments will be generated by amateur radio operators communicating with each other over and around the eclipse paths using medium frequency and high frequency signals that are refracted back to Earth by the ionosphere, and therefore sensitive to eclipse-induced ionospheric changes. These SEQPs will be coordinated by the Ham Radio Science Citizen Investigation, HAMSCI, in collaboration with volunteers from the amateur radio community. These experiments will build on the success of the SEQP held during the August 21st, 2017 Great American Eclipse, which generated over 2.5 million radio contacts over the 8-hour period around the eclipse. These observations were successfully modeled by ray tracing through an eclipse version of the physics-based first principle SAMI-3 model ionosphere. This allowed the amateur radio observations to be linked to physical parameters and provides a route towards model validation and data assimilation. 2 SEQPs will be conducted during this project, one for the North American annular eclipse on October 14, 2023, and a second for the total solar eclipse on April 8, 2024. The 2023 annular eclipse will serve as a trial run of the SEQP experiment and as a means of engaging and exciting the amateur community early in the project. Also, as every eclipse is distinct, having equivalent data sets from the 2017, 2023, and 2024 eclipses is important for making good progress on all research goals. This project will study the bottom side ionosphere's response to total solar eclipses specifically with the following goals. 1, assess the accuracy of the modeled predictions of the bottom side ionosphere during the 2023 and 2024 eclipses. 2, determine whether or not an onset recovery asymmetry of the bottom side ionosphere occurred during the 2023 and 2024 eclipses. And 3, compare and contrast the effects of the 2023 and 2024 eclipses on radio wave propagation to dawn and dusk gray line conditions. This analysis effort will consist of running the eclipsed version of SAMI-3 prior to the eclipses to obtain a prediction of the event. After the event, the observations will be compared to the SAMI-3 outputs. The differences between the observations and the model will be used to tune the model to best match the observations. This tuning will be used to understand the cause of model errors while simultaneously developing a method for closing the research to operations to research R2O2R loop. This project will be an important part of NASA's Heliophysics Big Year campaign, and that will directly engage thousands of volunteer citizen scientists in a meaningful way at multiple levels. Any comments or questions there?
We're also including, I think, 6-meter activity in the SEQP, and here you mentioned 3 to 30 megahertz. Is that significant, or are we just?
Well, this is what I wrote like a month ago, so that can be tweaked.
Okay.
So, I think that is a good point, and I think that's one of the things I really wanted to talk about today. I think we have I think the SEQP rules as they stand for the kind of contest side of things makes a lot of sense so far. I think they're pretty well developed, but I think along with that, there's a lot of desire to maybe do some things in addition to just the contesting part of stuff. It seems like, you know, there's a number of people who really want to do a little bit more controlled experiments. So I'm wondering if we should include some of that in the methodology here. The other thing I thought was nice is you sent out, Gary, about a week or so ago, a nice figure that kind of like, I think it was a triangle that showed the different parts. I thought that might be a good thing to include in the proposal. Let me see if I can find that.
If not, I could throw it up.
Could you just, yeah, can you just re-email it to me?
Yep. Let's see, this is in Keynote. Let me try to find the PDF.
Okay, that's great. Or if you can give me a PNG, that would be really good.
Okay, let me see what I can do. Why don't you talk for a second and I'll bring it up.
That sounds good. So we'll talk. And then the other thing, so far I've divided this technical approach and methodology into two sections: observations with a number of subsections, and then modeling with a few subsections. And then I was going to have this data model comparison part to try and tie the two things together. Here's the text about. So this is text at Joe Huba. Joe Huba is a scientist who retired from Naval Research Laboratories. He's the one that did the ionospheric modeling that we used the last time. So this is text he sent me today. So about the SAMI-3 eclipsed ionosphere. So he says, we will use the SAMI-3 as also a model of the ionosphere, SAMI-3, to simulate the impact of the total solar eclipse on the ionosphere. SAMI-3 is a seamless global three-dimensional physics-based model of the ionosphere plasmasphere system. It is based on SAMI-2. SAMI-3 has been used to make predictions of the Great American Eclipse of 2017, which included 1, the total electron content decreases by up to 5 total electron content units, which is a 35% decrease in total electron content. 2, the electron density decreases by a factor of about 50% in the F region. 3, the electron temperature decreases by about 800 Kelvin in the plasmasphere. And 4, the O+ velocity changes from about 40 meters per second upward to about 20 meters per second downward in the F region. In general, these predictions were confirmed by observations. SAMI-3 was also used to model the December 26, 2019 solar eclipse over Southeast Asia, and the simulation results agreed well with observations. The methodology to be used in modeling the April 8, 2024 eclipse will be the same as used in previous eclipse simulations. Namely, the path of totality will be calculated and a mask will be applied to reduce the solar extreme ultraviolet radiation as a function of space and time based on the path of totality. Nominal outputs of the simulation will be the electron density to be used in the ray tracing studies, as well as the total electron content to be compared with observations.
So this is obviously different than the IRI, the internet, what is it, the International Reference Ionosphere that I've heard about in the past?
That's right. So the IRI is an empirical model based on previous measurements, and it doesn't have any understanding of the physics that are going into creating those electron densities. It's just strictly monthly median measurements from a variety of sources. The SAMI-3 model actually is a physics-based simulation. Were you able to find that figure, Gary?
Yeah, I did send it to you.
Oh, you sent it to me. Okay. Let's see if it came through. I think my email might be slow right now for some reason, because there it is. I got it.
And I've been fooling around with the title at the top based on Ward's comment, so that obviously can be anything.
Great.
Festival, love it. Yeah.
So this looks very nice.
Section AM TDOA beacons.
I think if I include this in the proposal, I need to be able to point to someone who's running or organizing each of these things. And obviously I can do that for the SEQP. And I guess Whisper Party would fall under that as well.
Hey, Gary.
Yeah.
Yes.
What is TDOA, please?
Time difference
Time
of
difference
arrival.
of arrival. That's kind of Steve Serwin's area of expertise. There was some
That's what it is,
discussion on
time
that last
difference of
week
arrival.
briefly.
Okay, right. I remember him talking about that. Thank you.
That's Steve Serwin, right?
Right.
Yeah.
Oh, so that's referring to not AM broadcast, but WWV.
No.
Right, modulation type.
Well, that's
If
confusing.
I was going to
'cause-
transmit, and maybe some other volunteers transmit some chirp waveforms, and to avoid frequency errors, because two radios that think they're on the same frequency aren't really on the same frequency. If I transmitted AM instead of sideband,
Oh.
I won't have to worry about the frequency shift.
And
I
then
see. Well, just for myself, that's extremely confusing because we do AM broadcast beacons.
what
That's
if we changed it to HF TDOA?
Yeah, just
Yeah.
take the AM part out of it
Yeah.
and just use TDOA
Sure.
beacons.
TDOA or HF TDOA?
Yeah,
What's that? HF?
That sounds good.
Yes, if we say HF TDOA beacons.
Yeah, it doesn't matter how you do it, but that's the band you're going to be operating.
Okay. Yeah. And then Steve, would you be able to send me a paragraph or two explaining what you're doing in here?
sure.
Okay, then I could include that in the proposal. Because one of the things they like to see is that in addition to, you know, they like to be able to see the organizational structure, that we know what we're doing for each of these different things, and each thing has a leader behind it. Okay, let's see. So now Whisper Party, Gary, that's similar to the SEQP, it's just not scored the same way.
Right, exactly. And we may split up the rules or some such thing, but yeah, generally you're right.
Okay. And then let's see, Grape 2 Doppler event. That's going to be the one that's funded by CEDAR, by the National Science Foundation. So we already have funding for that. And we have In Case Western is behind that. And then the VLF reception exercise, that's what I'm doing with Morris Cohen. So Georgia Tech is essentially leading this one, and provided we get that funded. Who's doing top band trials?
That was just a placeholder to fill in that corner, that's all.
We could leave that, we might be able to leave that open for other community defined experiments.
Yeah, I can fit those 3 words in there, no problem.
If you have this, if you can just save it as a PowerPoint slide that I could change the words on, I can adjust it as I'm writing the proposal, because I find that as I'm writing, I often have to change the figures a little bit. But I like the idea of having a figure like this. And I'd also change this from 2023 to 2023/2024. Because one of the things you'll notice with the proposal, with the solicitation, is it specifically talks about the 2024 Eclipse, but not about the 2023 one.
Yeah.
And so when I write the proposal, I have to really right that we're doing the 2024 eclipse, but the 2023 one is like good practice for getting ready for 2024 or something like that. So
I'm curious, I know there's been some discussion of EME
well,
stuff.
I think that's where I'd change this from top band trials to other community other community led experiments. Because here's the other thing. These proposals, both NASA and NSF, they don't like you to be overly broad. They don't like proposals that try to answer, too broad of a question and have too large of a scope. But at the same time, we are going in. So I think our targeted science questions that I had right at the beginning constrain it fairly well. So if you look over here, we have 1, 2, 3, and we have a good methodology for answering those 3. So I think we have it constrained fairly well there. So while you're supposed to not be while you're supposed to be focused, there's this competing thing that we're going in under NASA citizen science funding. Like we want to say we're part of the heliophysics big year and part of NASA citizen science. And so that does give us a little bit of maybe additional resources than a normal project would have, because the whole amateur radio community is very large and there's a lot of people with different interests, so, and with a lot of different expertise. So I think from a citizen science perspective, it's reasonable to say that there may be other experiments that come up from interacting with the amateur radio community in a citizen science sense, that while we may not be directly addressing it with this proposal, we, the HamSci website, the HamSci ecosystem can provide some support to help engage people, and some of our time or resources could go to at least encouraging those things to come on up and happen. So that's why I think I would make this kind of that, other questions, and then in there I could include some discussion about the EME. Gareth, does all this sound reasonable to you?
Let me think about, yeah, sorry, I was just working on some of the
That's
paperwork.
okay. I understand.
Let me think here. I think that from what I heard seemed to make sense to me,
Okay.
but let me move back to, let me pay a bit more attention and take my mind off spreadsheet for a few minutes.
I totally understand. Mary Lou, what do you think?
I don't know, it sounds reasonable for me. I was thinking about a kind of pronounceable name for the TDOA thing, which sounds, you always have to say all these letters. And I thought if we could sort of sneak a little schwa in after the T, it would be ta-da! Like trumpets do. Ta-da! But maybe not.
I don't know.
I'll bet Steve would like that. That'd give him something he could walk around and Steve, you can
Only if it
Yeah,
works.
I thought Steve might like that.
yeah,
Yeah.
Steve can say, yeah, what are you doing today? Oh, I'm just kind of ta-da.
Yes.
Sorry, Steve, I couldn't resist.
We'll look at that after it's over and if it works or not
Oh, it'll always work in some way.
in some way.
Okay, I emailed you the PowerPoint, Nathaniel, so you should have it.
Great, thanks. Then I can, let's see, so I'm waiting for my email to come through again. I think this will be nice too, because now if we do get from the modeling perspective too, if we run the model once, the model we'll be able to make those model outputs available to everybody, right? So like say if Steve wanted to work with the model results, he would be able to and use them in the context of his experiment. So we could make those model results available to the general citizen science community.
Daniel, did we decide if we could use 60 meters or not?
Did we decide?
Or did we find out?
I don't remember discussing it.
We did talk about it once.
60 meters is very locked down. So they're very, it's all channelized. You can only have upper side band in there in the middle of the channel. I think it would be difficult.
Yeah, it would.
It would be a great band to be able to use for this, but I think it would be difficult.
I mean, there are signals there, and the problem I would see is that I don't think there's 60 meters has an authorized channel in the U.S. At least I'm not aware of anybody transmitting on 60 meters.
Oh yeah,
There's Canadians.
Yeah.
There's Canadians. I know Canadians. I get them, but I don't think I get a single 60 meter spot from the U.S.
No, we've got 5 frequencies available to it. And they're used all the
It's
time.
quite busy on FT8 right now. So.
Yeah, nobody's transmitting whisper on it. Yeah. So at least I'm, so I think if you wanted to, I think it's usable and it might encourage people to put whisper on there. But in terms of the whisper usage, I don't see any in the U.S. I'll have to go look and I can tell you if I'm wrong, but I don't recall any.
But if there's FT8, that's something too.
It was quite busy last night, speaking from experience, because I was on. So.
Okay, I think this is good. So I think when I write the proposal, I'm going to really incorporate this idea that it's not just a radio contest, so it's not just a radio contest. There's these other things going on as well. And I can point to other people who are leading efforts with these things.
I stand corrected. There's 3 or 4 guys on the East Coast transmitting whisper, or I think maybe they're receiving. I don't see a single transmitter.
Yeah, the regulations in that band are, to say the least, quite onerous because we're sharing it with a lot of U.S. Government users. So
Yeah.
it's tough.
Yeah, there's no transmitters. There's 1 Canadian transmitter. And nobody in the rest of the world. I mean, except for Europe. Yeah. Guy in Turkey, but nobody in South America. So I don't think, it'd be good to encourage it, but I wonder if you'd get anybody to set anything up in that shorter time, just for that band and whisper. We certainly could receive it. I mean, and if you had people, Canadians and South Americans and I don't know,
if we could get someone interested in the Montreal area, those of us in the Northeast could receive it.
Yeah, well, we could get somebody in. Let's see, the Eclipse path goes from what, Mexico up through the kind of northeast. I don't know the path, so I don't know where the good. What would be in fact, this would be interesting to me. What are optimal locations? Where would we get the most information?
Well, that's a good question. So one of the things I want to do, I go to my figures section here.
Well, there are 2 eclipses we're talking about. The first one starts in the northwest and goes down to the Gulf.
I like that.
And then the 2024 starts in Texas and comes up through the Northeast, New England.
There you go. So the dots that you see on here are the these are the black dots are where we're planning on putting grape receivers. The colored dots are the midpoints between the grapes and WWV or CHU. And of course, this is where the 2023 eclipse is going. Here's where the 2024 eclipse is going. So I was thinking of redoing this map somehow with like a day's worth of data from FT8 or WhisperNet to show data coverage and including that in this proposal.
So what, yeah, it'd be kind of in a way nice to score the locations or the paths would be, especially the paths,
Yeah.
ray trace the paths would be of greatest value for the study. And, and kind of encourage people to set up to send and receive along those paths.
Mm-hmm.
I mean, you got a lot of people on the East Coast transmitting and receiving, so that won't be big trouble. But your West Coast is a little bit sparse. I mean, there's, I mean, again, my perspective is totally whisper, though, which is a different,
Yeah, the FT8 PSK reporter has a huge.
Oh, you have plenty of. So the question is, what could whisper spotting uniquely contribute to your, this project, and how do we encourage people, the whisper community, to devote energies in ways that are most useful to this?
Well, I think your signal and noise ratio measurements are interesting.
Well, you certainly, and you'll have plenty of Doppler measurements.
Yeah, and that's going to be that will be interesting too.
Because my sites here in California and in Hawaii are millihertz accurate receivers. So on 20 meters, so they're almost that on 10 meters. So getting, as I've kind of repeated, and I won't belabor here, but getting whisper transmitters with that level of frequency accuracy is the challenge. I think we could do the best to contribute and complement the work with the grape stuff using WWV.
Yeah.
Right, Isma, right? Because you're going to only,
some Doppler measurements and also repeat some of the signal strength measurements that I did back in 2017 that showed a 10 dB increase in both WWVB and 5 megahertz WWV. In fact, if you'd like to see that graph, I've got it on the screen. I can show it to you. It was pretty cool.
By the way, all of the, I mean, I don't really know what grape measures in terms of WWV, but there is a mode you can configure my Whisper Daemon sites where they can log WWV and the frequency and signal strength of WWV. So I have one receive site in Utah that for which that's of interest. So he's been logging CHU and WWV. I don't even look at it. I don't know what value it is, but the raw data is, just comes from WAV files. WAV files have timestamps, 10 nanosecond timestamps on them, and the start times, and they're accurate to 15 millihertz. So you can easily see the Doppler from WWV. So maybe those could, I don't know how much, if any, effort anybody wants to put into it, but you could extend the kind of grape, at least the WWV reception, to almost any of the Whisper Daemon sites.
If we did that, does that end up having those Whisper Daemon sites not decode Whisper anymore? Then they're just dedicated, or are they able to do both?
No, they could do both. I mean, the the Kiwis at these sites are typically configured for 8 receive channels. So and the antennas infrequently can support 8 receive bands. So usually there's at least one free band, and you can tune it to anything you want. Or
Yeah.
And many sites have, like I have a KFS. I've got a half a dozen free receive channels.
Yeah.
So yeah, we could they're receive sites all along your with the Whisper Demon all along your both of your paths on either side of them and underneath them.
Now, I can say that for the 2024 April, when I will probably be portable in Texas directly under the pathway, and could be somewhere for the October 2023 that would make sense.
Well, it looks like the 2023 passes right over Utah receive site K7OEI-1, and that's a world-class receive site, super quiet, very well monitored and tested. So, but I don't know what it is you record with Grape, to be honest.
With the Grape, we just record Doppler shift of the carrier, and
that's it. Yeah,
pretty much. We're going to record the spectrum around the Doppler shift. So what you're saying, that you can provide wave files that have that level of accuracy, that's basically what the Grape is doing.
Yeah, I can. Yeah, we can provide, and there's a mode that Whisper Demon can be put into. It's configurable mode where it just continuously saves away all of the wave files and caches them locally. And depending on how much storage you have, local storage you have, it's how many hours or days of storage. At KFS, I've got about, 7 days of wave files on about 28 different receivers. I got enough space for it, so it doesn't cost anything. It's rotating media; it doesn't wear out. So, yeah, there's a tremendous. In fact, I was thinking that would have been of value to the HARP experiments.
Yeah,
but I didn't have time to do it. This is all kind of needs a little bit of experimentation, since I've never really given any of this data to anyone. So if someone is interested in the data, there's 60 Whisper Demon receive sites that could give you WWDV data wave files if you wanted them, and they're not as accurate as the Tangerine, but they're at least an order of magnitude more frequency stable than Doppler shift. So
it sounds like we have a lot of options for the data collection, and I think I'll be able to. Is there anything I should be adding to this? I know we talked a little bit about the EME. Make a note here about EME. Possible EME and the top band trials. Is there anything else I should be adding to this?
I think you ought to solicit Doppler spectrograms of WW.
Of what?
Of WWV at 5 megahertz.
Well, that's under the Grape 2 Doppler event.
Is that going to be part of that?
Yes.
So they're just looking at WWV and not at ham stations.
That's right. Yes.
One of the things that might be
it's amplitude as well.
What's that, Steve?
The Grape reports amplitude as well, doesn't it?
Yeah. It reports it will be a full spectrum. So our goal is to make spectrograms similar to what you're doing in the with Spectrum Lab.
Yeah, during the 17 eclipse, even though the path from WWV down here, the whole path was completely south of the path of totality, it made a big difference in propagation at 60 kilohertz and 5 megahertz, at least in amplitude, 10 dB worth of difference.
Yeah.
One of the things that's going to be interesting with this is the differential between solar noise, in other words, noise from the sun, versus the reflectivity of the ionosphere. When you're trying to do, especially when you're trying to do EME, in this setup of the solar system, the moon is going to be directly in front of the sun.
Mm-hmm.
So you're going to get, as the moon moves through the sun, and it will move directly through the sun, you're going to get big changes in both the solar noise coming down, and the reflectivity is going to change in the ionosphere because of the UV and other things ionizing the ionosphere.
Right.
So this is an opportunity to study that.
Yeah. So Rob, in your whisper demon noise measurements, do you think we would be able to see that reduction of noise?
Oh yeah, we can see the Sirius A galactic noise at KPH when it's so yeah, definitely we'll see, I mean, again, it's a function of the antenna quality of the site, but most of the whisper demon sites are easily are atmospheric noise limited. So you'll see, we'll see them all over the place. They're all being logged. It's all that data is in the whisper demon database. There's even charts that we put up for the last 24 hours for many of the sites. Upload a kind of eye candy chart which shows the background noise level on all of the bands over the last 24 hours.
Are you able, do you have a good one? Do you have a good figure chart where it shows that noise reduction? Do you see a noise reduction at night as you go from day to night?
Well, if you have a good receive site on 40 meters at KPH, there's a 20 to 30 dB day to night noise reduction. In fact, that diurnal variation in background noise level is probably the best single indicator of the quality of your receive site. You can basically treat the sun as a signal lever generator, and if a site doesn't show day to night variation, then that means that the atmospheric noise or the local background noise level or the whole receive system isn't atmospheric noise limited.
Could you send me an example figure of this that I could include in the proposal?
Sure. Yeah.
Okay.
Yeah. There's I'll show you a good one and a bad one.
That'd be perfect. Yeah, if you could send both.
Yeah, but if you're going to make those measurements at a site, you probably it would be a good idea to go and do that, because if even if you're not going to do whisper reception, if that isn't of interest to you, it's a good way to determine if your site is actually looking at solar noise, solar generated noise during the day. Because if it isn't, then you're not going to be getting good noise level data for with whatever system you're using at that receive site.
Yeah,
So,
that's good to know.
that's why it's a really good idea to set everything up ahead of time and start start making measurements and looking at it ahead of time, so you know that what you're actually going to be receiving, that you're actually going to have useful data. I mean, here's a quick one. I'll just can show you if you, well, you're showing things, but anyway, there's yeah, there's on 80 meters, you're going from minus 150 per hertz to minus 125 during the daytime. So that's a 25 dB change. Of course, it's a function of the solar weather conditions, and of course affect that. But on 20 meters right now, there's about a 15 dB change maybe.
Yeah.
So a day to night. So even 15. Whoo, wow! I haven't been looking at these graphs, but even you can see 10 meters opening up. You can see the day to night noise transition. So yeah,
Can you show us?
yeah, if you want to look at it, just allow me to share the screen here. I'll show you
Go
what.
for it.
Okay. Let's see. Where is that? I have so many. Oh, this is a different advanced. No, that's it. Let's see. Desktop. It's showing me every screen but the one I want to show you. I'm scrolling. I got so many windows open on my computer that it's really, let me try bringing that forward and see if Zoom will, hold on. Let me bring, oh, there it is. I see it. There it is. Okay, share. Here's the last 24 hours of KPH up here in Point Reyes. Now, so you can see this is UTC on the bottom, and of course for us nighttime is about 0. Evening is 0 UTC. So you can see the noise level going up at the band 80. This is individual receivers, so in different bands and different. They're all the same antenna. There's a single antenna, but different bands. So there are two ways we measure noise, and I won't go into the details, but they generally correlate, but they don't always. And that's always a subject for study, but we haven't done. But you can see.
So how much of the noise do you think is noise that's solar noise versus how much of it's being propagated in from other places on Earth?
Well, that's a function of the how much, I mean, the propagated in noise. I mean, what's it coming from? I think in the wintertime, I mean, summertime, it's propagated as thunderstorms and distant thunderstorms. In the winter, I don't know. You guys would know that better than I.
Because I'm looking at these figures, and I want to make if I include this in the proposal, I want to make the case. I'm like, okay, we expect the solar noise to go away. Well, here you're seeing less noise at night on the high bands and more noise at night on the low bands, right?
Mm-hmm. Yeah.
And so I could say, well, it's not that you're getting a reduction in the solar noise, it's that the noise is being propagated in from other locations on Earth. And on the high bands, the bands are, shut down, propagation shuts down, so they get quieter. And conversely, the low bands are showing an elevated noise. And that's because the noise is getting propagated in from farther away.
Yeah.
You haven't mentioned galactic noise.
No, I haven't mentioned galactic.
That's probably what you're seeing on the low bands.
Oh, I don't know. We did a
Galactic
study.
noise dominates on the low bands.
Yeah. Well,
I feel like if I'm going to go and if I go in and start talking about solar noise on here, in the proposal, I think I have to be very careful how I say that, or a reviewer I think will, kind of rip that to shreds.
I think you're right to be careful. Also, these are omnidirectional antennas, and you know, for this exercise, I can see the point of having something as directional, vertically directional, that would give you, you know, try to exclude the effects of propagated noise, background noise. And I don't think I've ever, you know, I know we've never done such an experiment. We did a study where we looked for the Sirius A noise, and we did find a 2 or 3 dB bump, which we associated with it around 20 on the 15-meter band. But that's the only study, and these are you know, I think that if you're going to do solar noise background, I think you'd want to do anything you could to exclude the effects of propagated noise.
Absolutely.
Yeah, so I think so that would be a kind of specialized antenna. You know, take your 5-element 20-meter beam and point it toward the sun.
It won't be enough, but you might be able to co-opt HARP into helping you out. They've got a pretty directional HF antenna. And I think they're pretty close to the path too, up there in Alaska.
Who is this?
HARP,
Oh.
High Altitude Auroral Research.
Oh yes, oh yeah, okay, yeah.
They got a giant array that can put a
they got a giant array. Well, that would be a great site if we could hook up a Whisper Demon receiver to that array. We could get some great during the. I'll go up and hook it up. That would be fun.
they do have a call for community proposals for HARP. So anyone who wants HARP time, you can actually apply for some.
Well, anyway, I mean, there's graphs like these for a bunch of sites. Here's and then I'll give it back to you. You could look at here's KFS, which is nearby, and which has the same antenna system, but literally the same antenna, the TCI 530. But it also has some other antennas, directional antennas. The Omnis are so you can see it's doing pretty well on 40. You can see a -40. We made a stab at making these calibrated in terms of, you know, it's hard to do a, you know, antenna factor calibration. We don't have the equipment or the time to do it. So, but this is our guess at what the proper, you know, the absolute E field intensity of the noise is. So you can see they vary pretty much the same. Those are two pretty good sites. And then things go downhill from there, which you could look at other sites.
Could you
but
show
all that data sitting there? What's that?
Show us one bad site.
Bad site. Well, let's see. I always work with it. I tend to work with the good sites, so I don't have to. Let me think of somebody out there who is struggling. Oh, okay.
Is it usually urban versus rural, that sort of thing, or what?
No, not really. No, he doesn't have any. The site I was hoping would have bad spots isn't posting at all right now. Let's see. No, this isn't probably another. No, this is all these guys are the guys that are posting that I know. Well, here's a guy who here's a site that doesn't do nearly as well. Okay. Although he's where's the Zoom window here?
Are you going to redact the call signs of people who don't perform?
Oh no, we have these are all my friends. They'll be happy with this stuff. They don't care. Let's see, where is this Safari noise analysis? Here's this is Steve KD2OM, and he's in Rochester.
Okay.
He's in rural. He's outside, but you can see that he is. You know, you can see relatively small diurnal variations in his noise level.
Yeah.
Okay.
Huh.
So I think he has a lot of room for improvement. Although he is actually one of the best whisper receive sites in North America. I think he could do considerably better than he is already.
So what does he have to do?
I don't know. I have, these are, he has a, I don't, there's a whole series, there's a long, if you, I could, there's a day-long seminar and, people do on optimizing your receive antenna, RF system. But and I'm not the most qualified to do that, but I do have some, many sites are not limited by the noise that's in the atmosphere at their location. It's due to the a noise that's introduced by the feed lines and the ground loops and other sources that are picked up by the signal distribution system. And so you just let's try. Let's see if this site has any. No, he isn't posting much, so you can't see anything there. Well, there's these are all OE and let's see GHB. Here's a Austrian site. He is one of the best in Europe. He's up in a rural area on top of a hill. So I think he has the opportunity to do better, but he still does very well. That's an top Austrian site and a BFK. Let's see, this is in Canary Islands, and he's got so many receivers. I mean, the charts get squashed, so you can't really tell. But this is actually the top receive site worldwide. He gets the most total. He'll get 60,000 spots a day, and 2,000 different call signs logged. So anyway, these are charts that are extracted from the database. So the data is also all of the data is sitting there, going back for at least a couple of years on all these sites. So anyway, I'm sorry, I didn't mean to hijack the discussion, but that's there. I think that the noise gathering, if you're gathering solar noise level data, that would be a real specialized but an interesting project. But it would require, I think to do so usefully, it would require somebody having an antenna that's vertically directional on the bands.
Yeah, and I'm very nervous to write that into the proposal.
I wouldn't write it in the proposal, but it's interesting to talk to. It's interesting to talk to HARP.
Yeah.
The HARP guys would be. You're right. It would be interesting for HARP. So,
big phased array system.
Yeah, they have the right system. I mean, the other place that would be interesting is VK0 ERC up in near the magnetic North Pole. That's a Whisper Demon receive site, and that site might get some unique effects during the eclipse, even though it's not on the path. Perturbations of the magnetosphere that occur might propagate up there in ways that would be interesting. I don't know. You guys know better than I. I'm here to offer you data.
Yeah.
You know what's useful.
So we're at 5 p.m. Eastern, so I'm going to have to go soon. But let's see. I think Gareth just hopped off. I guess he just hopped off. Oh, Gareth, he's back. Yeah, that sounds really good. So I think what we'll do is I have some time blocked off in my schedule tomorrow afternoon and Saturday, and I'll be working on trying to draft up this proposal. Steve Serwin, if you could send me a paragraph or two about what you're doing. Rob, I think I know what you're doing.
I worked on the. I did work some on the Q, the bonus thing that.
The bonus thing. So I can go take a look at those rules.
I looked at the rules some. I could craft some categories that my Whisper Demon sites would absolutely win. I don't think what is more important to me is that whatever we do is to encourage the kind of data collection that would be of greatest value to you guys. That's really my goal here, is not to, and my thought on that is that what would be the most useful would be the Doppler shift stuff. So, with the 4W transmitters, and I think we have a low cost 4W transmitter solution. soon.
Yeah.
So I think that's a real possibility. So the I would like, for myself, I would think that would, from my perspective, getting those transmitters out as many sites as we could would be a valuable complement to the grape data on WWV, because you'd be basically getting a whole bunch of different paths,
Yeah.
not just, receive site to WWV or CHU,
Mm.
but any 4W transmit site would, in essence, have the same frequency stability and in your ability to analyze the characteristics of the thing as Grape does from WWV. So
Yeah. All right. We'll think
okay,
about
anyway,
that some more.
you think about it.
Okay, so what I'll do is I'm going to try and take all of this. I'm going to try and write up a draft of this. I have to have a draft that reads from top to bottom by this Tuesday because I'm required to. But then I'll be emailing some of you throughout the weekend or whatever if I have questions or need some input. And then for next week, what we can do is hopefully I'll have that top to bottom draft. I can distribute it to the people here, and we can hopefully put on some, polish it up, address some final questions. And as I said, even as long as we don't make changes to the budget, we can actually make quite a few changes to the structure of the science technical management section, pretty much right up until the last minute. So I think that's about it. Thank you very much, everyone. I really appreciate it.
Great. Hey, Steve, could you stay on for a second at the end of the recording?
Yeah, sure.
Okay.
Thanks for the invite, everyone.
Thanks, Ed.
Right.
Good seeing you.
All right.
Bye.
Take care, everyone.